Hi guys, Mr. Sandham here. So we're continuing our lessons in chemistry, and this is the first part of two lessons this week. So the first lesson for this week is being able to read and understand chemical equations, whether it's a word formula or the format like this, which is called the IUAPAC, the UAPAC. We need to have our acronyms, don't we? It's the official chemical formula, which is recognized throughout the world. So the reaction we're going to specifically look at this week is the decomposition of hydrogen peroxide or elephant's toothpaste. Now today we're looking at how to read these equations. The next lesson this week, we're going to take a look at how we can influence the rate of reaction by changing temperature or adding a catalyst or something like that. And in this reaction, we actually use potassium iodide as a catalyst to help the reaction occur. Now, those of you who were in my science option class term 3, we actually got to do this lab. Unfortunately, because the school year was interrupted, you guys weren't able to do it, but everybody else, we would have been upstairs performing this experiment. We got some different results depending on concentrations of the solutes and things like that. So this is a video that I found on my YouTube channel from a couple of years ago. I had one of my student teachers do this, so no, those aren't my fingernails when you see the person adding the catalyst. She's actually a grade 9 science teacher at George McDougall this year, I believe. So in this reaction, what we did is we put hydrogen peroxide and dish soap in an Erlenmeyer flask. We add the potassium iodide powder, and right away it causes the extra oxygen molecule in hydrogen peroxide to release. Now you see all of this steam being given off here. That means it's an exothermic reaction. This foam that's released is actually quite warm to the touch. What we see happening is the hydrogen peroxide, which is H2O2, 2 hydrogen and 2 oxygen molecules combined together. We see that the one oxygen molecule is being separated from that compound. And as a result, there's a fair amount of energy being given off. It takes the potassium iodide, that catalyst, to cause the reaction to happen. So we take a look at chemical equations. They use chemical symbols as a shorthand way of showing what happens during a reaction. Here's the chemical equation for what we just saw, the decomposition of hydrogen peroxide. This is hydrogen peroxide right here. H2O2. The numbers mean something more. We'll take a look at that in Science 10. Essentially what this means is there are 2 hydrogen atoms and 2 oxygen atoms, and altogether there are 2 hydrogen peroxide molecules that go into this reaction. These arrows that we look at here, this black arrow, we would read that as combine to form or makes. Now on the left side of reaction, we always have the reactants. They're what cause the reaction. On the other side of the equation, we have the products, and obviously they're what's produced by the reaction. Now, it's also important, keep moving the screen up and down there, sorry. It's also important that we know what the different symbols mean for each element. We're going to spend some more time on this next week looking at the periodic table of elements and just some of the more common elements you're going to need to know for this course and for Science 10. So when we look through these, K stands for potassium. Hopefully you might remember that from grade 7 science when you looked at nutrients and artificial fertilizer. The I stands for iodide, and by now everybody pretty much remembers that H stands for hydrogen and O stands for oxygen. When you're putting the chemical symbols in the equation, it's also important that you try to put them in alphabetical order if possible, but sometimes there's different rules that happen here because this is a certain type of compound. There's a lot of rules to writing chemical equations and compound names. It's also really important for you guys to know that the catalyst, the potassium iodide, doesn't actually get used up in this reaction. The potassium iodide here is just used to separate that one oxygen molecule here and give off that energy. A catalyst is something that speeds up a reaction. You might remember that from our definitions, and we're going to take a look at this in the next lesson here in a little bit. Now, word equations are much simpler. There are far fewer rules than when we look here at the chemical equations. So for word equations, we just use words to describe the reactants and products. At the grade 9 level, you're just expected to be able to read word equations. So basically, here's how it works. We still have the arrow, and we're going to start with the chemical equation from the previous slide. And here's how we would read it. Potassium iodide and hydrogen peroxide combine together to make water, oxygen, iodine, and potassium. It's a lot simpler than the way that we read it before. and something that you guys are going to be practicing more when you get into Science 10. Okay, there's no assignment for this part of the video. This is just going to help make the next part of the lesson to make sense, okay? Your assignment is actually some questions that are based on the next video. So after you finish this, take a look at the rate of reactions video that I've posted. And there's also a TED Ed talk that you can watch as well. And then there's an assignment with 10 questions you need to answer. If there's anything that you guys need help with or anything you didn't understand, you can play back this video or feel free to email me, give me a call, contact me on Google Chat or Google Hangout or Google whatever. And I'll see you in a minute in the next video.